Okay, give me a second. I will set up the window, I mean the screen. Okay, so this video explains you, I hope now the video is fine, right? I hope that there are no issues with the video. Earlier, you said that the video is lagging, but I think now it's fine, right? Is it fine now? Okay. Can you see it now? Can you see the video now? Okay, right. So now with this video, I will explain you what the morphological operation is about, right? So this is what you have to understand now. Let's say that there's an image and this is called the input image, right? So this is called the input image and this is the output image, right? So what we are going to do now, we are going to get a kernel, right? So you are aware about kernels, right? So I'm going to get a kernel, right? And let's say that we have black color pixels and white color pixels, right? So these are black color pixels and these are basically white color pixels, right? So what we are going to do now, we have a kernel. Now you are familiar about kernels, right? So let's say that this is the kernel, right? So then what we are going to do is, now you know when it's like when refer to the neighborhood operations, right? So in neighborhood operations, a very simple thing happens, right? So there will be arithmetic, I mean the weight, the values of the pixels will be multiplied by the weight values and the addition will be assigned to the center value of the output image, right? So you can remember, so when there's a kernel, what it's going to do, it multiplies, I mean, it's going to get the sum, weighted sum of the pixel values and the kernel, the values in the kernel, and they will be added together. And final value will be assigned to this center pixel. You know that, right? Center pixel. So that summation will be assigned here, right? So that's how the kernel operation works. We know that. Now, but in morphological operation, and here the first one we are going to discuss is the erosion. So this example is about erosion, right? So there are four main types of morphological operations available: erosion, dilation, opening, and closing, right? So we are going to explain, I'm going to explain you about the first type, that's erosion, right? So in erosion, what happens? There will be a kernel, and that kernel, don't worry about that kernel's value, right? That kernel will be they are like this, as I mentioned, as I told you, the kernel is there. So what you are going to do now, how this center value is assigned, right? So you know that, right? Now, how that center value, I mean, this value, the output image's center value, that means corresponding to the center of the kernel of the input image, right? The corresponding pixel to the center of the kernel in the input image. This is the output, I mean, that's the corresponding pixel of the output image, right? So what in erosion, what happened, right? In erosion, what happens simply, this kernel, right? So now this pixel becomes black, right? This pixel becomes black, right? When this kernel is placed, right? Now, when we are going to place this kernel, right? If at least, right? I mean, I will say it like this, right? In order to like this pixel to become white, right? In order to this pixel to become white, right? All of the pixels that is covered by this kernel, right? all of the pixels that covered by the kernel in this input image have to be white, right? Got the idea? Now, right, so this is what happens. Now you can see there's a kernel, and if all the pixels in the input image, I'm talking about the input image, right? If all the pixels in the input image, right, that covered by the kernel, if all the pixels in the input image that are covered by the kernel, if all the pixels are white, right, then what happens? This pixel becomes white. Otherwise, it becomes black, right? If at least one, right? So let's say if at least one pixel covered by this kernel, right? So this kernel, if at least one pixel is, like, let's say covered by this kernel is black, then this pixel, the center pixel, becomes black, right? Now you can see, okay, in this place, what happens? You can see that all the pixels, I mean, like the 9 pixels, right? Out of the 9 pixels covered by the kernel, you can see only a single white pixel is there. So you know, right, this will definitely become black. Why? What is the like requirement in order to like in these pixels to become white, I mean black? That at least there should be at least one black pixel covered by this kernel, right? So that's the requirement, right? Now what will happen if you now here, now 2 pixels are covered, right? 2 white pixels are there, so therefore this is black, right? Again, right? So that's black, right? Okay. So then see, right, black, right? Now you can see, right, right? So now here you can see like 3 pixels are white, but 4 pixels are black. So therefore what will happen to the center value, right? So that will become black, right? So let's see, right? Now how many pixels are white? Now here the kernel covers like 6 white pixels, but 3 of them are black. So therefore this also becomes black. Got it? Right? Now here what you can see, all the pixels covered by the kernel are white, right? All the pixels covered by the kernel are white. So therefore definitely now the requirement is satisfied. Therefore this pixel, I mean this pixel, right? So this will become white, right? This will become white. See? Right? Now what happens? You can see, okay, 3 pixels are not white, they are black. So therefore this pixel becomes, right? This pixel becomes what? That pixel becomes simply black. Right? So can you understand what happens? Right? Right? So this is called error. Now here, like you can see, right? Here all of these values, right? So they become white, right? So now you can see, right? So you can now clearly see that this do some sort of erosion. I mean, this is called erode, right? Eroding, right? The noun is erosion. Why? Erosion in the sense, now this erode, right? Got it? Right? So this erode this image, right? You can say it was like right? Now it getting smaller and smaller, right? It's getting smaller and smaller, right? So this is called erosion, right? Got it? Now See, got the idea, right? So that's what you call erosion, right? So what's the use of erosion now? Let's apply erosion and see. Now we have a sample image called J, and I'm going to read it and I'm going to show it to you, right? Then if I apply this kernel 1111, right? So this 11 is nothing, like it's like all the elements are 1. So I'm going to apply this kernel. The function is erode, right? So what happens when we do erosion, right? So you can see like the iteration is how many times we are going to take this, how many times we are going to take this kernel throughout the image, right? So then we are going to, that's the number of iterations, right? So how many times we are going to go through the whole image, right? So that's the iteration. And this is the image and this is the kernel that we are going to apply, right? So what happens when we apply this 11111, right? So that means all the pixels need to be 1, right? All the pixels need to be 1. That means white in order to become the center pixel white, right? You can give a customized pixel as well, like, I mean, this kind of a thing. So if you do it like this, now what happens here? Then if you do it like this, then the what you call the kernel is, I mean, the right, then the kernel is something like this. So this is going to search for this kind of a shape, right? So if the shape is there, then only this whole shape should be there, then only that center pixel becomes white, right? Got it? But usually what we use is this shape, right? Okay, so then after erosion, let's see what you are going to see. Now you can see you are going to see some sort of a eroded image, right? Eroded image, see, right? So it has become thin, right? So it has become thin, right? So if you put 2 iterations, that means the what you call the erosion done twice, right? So the kernel will be taken through the image twice, right? So then you are going to see a more thinner eye, right? So if you put like 3, that's taking the kernel 3 times through the image, right? So right. So if you make it more, then this image will be, I mean, the shape will be lost, right? Right. So then the dilation is the opposite of erosion. Let's see, right? So then there is another example that I have provided, right? So now this erosion is good for right? So it's good for removing, I mean, like removing what you call yeah, I will explain the applications, right? So I will explain the applications later. Let me go through the dilation first, right? So dilation is this, let's see, right? So when the kernel is there, so this is what happened. When the kernel is there, if at least 1 pixel covered by the, if at least one pixel covered by this kernel is white, then the center pixel becomes white, right? At least 1 pixel covered by this kernel is 1, at least 1, right? Then the center pixel becomes white. That's the thing in the dilation, right? Got it? Now, since no pixels are white here, you can see no pixels are white, so therefore this is black, right? So the requirement is at least 1 pixel should be white, then the center pixel becomes white, right? So let's see. See, right? Now a single pixel is white, so then the center pixel becomes white, right? So now here you can see, right? Since this pixel is white, the center pixels of the center pixel, the corresponding center pixel becomes white, right? So this is called dilation. So this, right? So this is kind of enlarge the image, right? So this enlarges the image, right? So now you can see there was a kind of a cavity or hole, we can say. That hole is simply removed. Why? Now here you can see this is the kernel and like, right? So like, I mean, 6 pixels are white. So therefore this center pixel, this one, that one becomes white, right? So therefore that hole will be removed, right? Got it? So it fills, can you see? It fills and it enlarges the image, right? So that's what you call the dilation, right? Got it? Hope you got the idea. So let us let me show you this thing, right? So let me get this image, right? So this, the same image I will get, right? The same image, this image, right? Then what I'm going to do, I'm going to apply the, right? So you can select a kernel you like. Then I'll apply dilation, right? So then when you apply dilation, you can see, okay, this is the input image and this is the output image, right? So it's like basically got larger, right? Thicker, right? Not thicker, but right? So it got enlarged, right? A bit. So if you put 2 iterations, so you can see the, right? So it's getting, right? It's getting larger and larger. The shape is getting larger and larger, right? Got it? So that's what you call the dilation, right? Dilation. So then we have another type called opening, right? So opening simply refers to like erosion followed by dilation. That means first we are going to like perform erosion, then we are going to perform dilation, right? These functions are only applicable for white and no. These things can be applied for color images as well. It's fine, right? This thing can be applied for color images as well. I want to basically verify that. Let me see, right? I'm not sure about that. I think it is possible, right? So let's say we'll get this image, the color image, right? So then we'll try to apply the thing. Right? No, this could be applied for color image as well, right? So then the erosion will be performed, right? Okay, so it could be applied for color images as well. So then the opening one, right? Third type of morphological operations, opening, right? Simply opening refers to the erosion followed by dilation, right? So erosion followed by dilation. That means first we are going to apply erosion, then we are going to apply dilation, right? So it is quite useful for this kind of application. Now let's say that there are some noise like this, right? Some noise like this, right? So let me show you, like now this is the image. So this is called the opening, right? So this is the image. So let me apply erosion separately, right? So I'm going to apply erosion separately to this image, right? See, not that one, sorry. Yeah, so I'm going to apply erosion here, yes, right? See what you can see, right? I'm going to like apply erosion just once, let's say, just once, right? Okay. Now can you see, right? So this was the image, the opening image, right? So then what I did was I applied erosion only one time, right? Then what you can see is like, yeah, it's fine, right? I mean, fine in the sense, due to the erosion, these these white dots are removed. That's obvious, right? That white things will get removed. But also the original shape of the image also disordered, right? Right. Original shape of the image also got damaged, right? I mean, it got thinner, right? It was damaged. It got eroded, right? Eroded. So then what we are going to do, like we can reconstruct this. How, right? So now after applying erosion at at the first place, later we can apply dilation, right? So then, for example, if we apply dilation for this image, right? After applying, now this is the original image, then we applied erode, our problem got sorted. Our problem was these noises. Those noises was neglected. Those noises was removed, but now there was another consequence that was like, our image also got like thinner. It also got damaged. So in order to reconstruct, now we can get this eroded image, right? This eroded image, and then we can apply dilation, right? So then see, right? So we can see something like this, right? So the thing is, you can see like, there are these small dots here, right? So that small dots got enlarged due to the dilation, right? Now this is what happened. Okay, so we got this image, and then we applied erosion, and erosion removed this, but we can think it's removed, but there are tiny little, these dots are there, right? So when we apply dilation again, those got enlarged, right? So what we can do, like we can apply erosion twice, probably, then those white things will get removed. Yes, now let's see about, yeah, now you can see it's fine, right? Now even we can apply dilation 2 times. See, so we got the original image back. Original in the same as, like we got only the noise removed. No, we haven't done any damage to the letter, right? So the same thing could be done at once, right? So if you are going to do it once, right, that is called opening, right? Opening, right? So how we are going to perform opening? Opening is just nothing but applying erosion first and then dilation, right? So for example, this is how you are going to do it once. No need to do it manually twice, right? You can get the image, right? Then get the image, then you have to perform like morphological open, right? So morphological X image, then you are going to perform open, right? Then you are going to say what's the kernel, right? So this is the output that you are going to get. So everything done once, right? At once, right? So the last one is closing. So closing is the opposite of open, right? So in opening, we are going to perform erosion first, then we are going to perform dilation, right? So in closing, what we are going to do, first we will perform dilation, then you are going to perform erosion, right? So this kind of image, we can use that, right? So what I mean, now there are small cavities, right? Small cavities in this letter, you can see, right? So what we can do is we can perform dilation in order to fill that, right? So in order to fill it, we can perform dilation, right? So we will perform dilation here. You can see, okay, sorry, not this one, right? Yeah, you can see due to the dilation, these cavities will be removed, right? These cavities will be removed, but you can see that, right? The original image is also changed. Changed in the sense like it got larger, right? So it got large, enlarged, right? Scaled up, we can say. Not scale, but it has got enlarged, right? So what you can do, like, okay, these things are removed now, right? These cavities are removed, but our original shape is also changed. So in order to get the original shape, we can then apply erosion and we can remove the effect here, right? So that could be done easily using a single line of a code, right? So what you can do, earlier we perform open, now we are going to perform close, right? So what we can do is we can get the image. Okay, this is the image, so there are cavities. First we are going to apply dilation, then we are going to apply erosion. So that's called closing morphological operation. So this is what we are going to see, right? Okay, so those are the 4 main types of morphological operations, and as I mentioned, this comes under neighborhood operation. So what's the application of this, right? What's the application of this? So I will show you the application, so then you can understand. Yeah, so I will show you a image, right? So this is the image. there's a brain tumor, image of a brain tumor. Let's see. So now what I'm going to do is I want to, let's say I want to, now let me show you the image, then you will understand. Image, it's, I mean, only the image. Let me show you the image. So this image, let's say that our target is to detect this tumor, right? So detect this tumor, that's our target, let's say. So we are going to do what? Now we have defined, I mean, this is a color image, so we can like apply thresholding or we can apply color segmentation. Now we are going, now these values are predetermined by me, right? So I'm going to get this range. So this is a gray range, and I'm going to apply a mask, and then like how, if you are wondering how I got these two values, like that's by trial and error. I checked these values and got these two values, right? So if I show you the mask, this mask shows you this kind of an image, right? So what I'm trying to do here is to like extract this, right? Extract this area, right? Okay, so you can see that's not like this. This is what we are going to get. So we want to get this part highlighted, right? So what I'm going to do, right? So if you now apply whatever this, right? If you now apply the contour operations, right? And let's say that we are going to apply contour operations and right? So I'm going to apply contour operations, let's say to the mask, right? And I'm going to detect the contours larger than 400, and I'm going to, let's say, draw rectangles. This is something that you are already aware, right? So we did contour operations, right? So I'm going to apply contours operation for this mask, right? So this is what you are going to get, right? So as you can see, let me reduce the area size, right, bit. So you can see like there is an issue, right? There is an issue in the sense like unwanted things are also detected, right? So why? Now you can see due to, I mean this image, what, like when we apply these two colors, right? The whole tumor is not detected. Some parts are that, I mean some parts are removed, right? So you are going to see small kind of right pieces, right? So in order to like get rid of this, and like if you can detect the whole tumor, if you can reconstruct the tumor, now this is what you are having up to now, right? This is what you have after applying the color segmentation. Now what I'm going to apply, I'm going to apply closing, right? I'm going to apply closing. So in the closing, what happens? First we are going to apply dilation and then apply erosion. So what's the purpose? So what's the, like what we are expecting? Simply we are expecting the morphological operation. Since we are applying dilation first, we are going to assume that okay, the small parts will get filled, right? And the tumor will be reconstructed. So that's what we are assuming, right? So let's do it, and later in order to, I mean, now let me show you first, right? So if we apply morphological operations, what we are thinking, I mean what we are going to think, simply when we apply opening, we are going to like believe, we believe that okay, these parts will be filled. Why? In closing, the erosion will be applied first, right? So we are going to assume these parts will be filled, right? Then why we are going to apply erosion later? Like these parts will be also become get large, right? So these parts will also get large. So in order to remove that effect, we are again applying erosion, right? So that's the purpose. So let's see will be success or not. So we are going to apply not to the mask. We are going to find contour not to the mask, but we are going to get the closing, and let's see what closing is going to give us. Right? So you can see this is the closing, the output after, I mean, okay. So let me show you the code, right? So simply now this is the original mask, right? So this is up after applying what, the closing, right? The closing thing. So then you can see that this got reconstructed, right? And the other effect remains as it is, right? But due to the closing, this became, right? Now, what happens when you apply closing? First, we apply dilation. So you see that these parts also become large, right? Will become large, right? In order to remove that effect, we are applying closing at the second time, right? So then that effect will get removed, right? So that's the purpose of having contours. I mean the closing, right? So now if we like draw it, I mean the area, right? So this is pretty much right. Now you can see it performs well, right? This performs well than the earlier case, right? For this kind of applications, we can use morphological operations, right? So then the next one, let me show you the next one. So next one basically is about these coins. Let me show you these coins that I'm taking example, right? So I'm the coins image that I'm taking as the example. So if you run this one, okay, so this is bit large. So let me first resize it, right? So I hope that I didn't, as I remember, I didn't explain you about this resize command available in OpenCV, right? So the resizing is basically to resize the image, right? So that means in order to enlarge or in order to like zoom in or zoom out, right? So changing the resolution of the image, the resize is there, right? So what we want to do, what we have, the first parameter would be the input image. Then we have to provide the size. Size in the sense like the expected resolution. Now, for example, if you want it 100 by 100, then you have to provide the size as a tuple at as a second parameter, right? The first parameter will be the input image, then the resize, I mean the destination size, right? So if I ask you it to resize to 100 by 100, it will resize it to 100 by 100. Let's see, right? See, so we can give whatever size we are expecting, like okay, 500, 400, let's say, right? Got it? So we can use this resize function. It will resize the image as we want, the size we want, right? But thing is, issue with this method is like we can give our own height and width. Now this is the height and this is the width. So the issue is like the ratio, right? The ratio will be removed. The ratio between the height and the width, right, will be removed if we use our own sizes here, right? So that's the issue, right? I mean, like the ratio in the sense there's a ratio in the height and the width, right? So if you change the height and width as we want, then the image will get shrinked or chopped, right? The ratio between the height and the width get removed, right? So in order to get rid of that, what we can do is, this is the method. Now here we can say, okay, so this is like 0, 0. We have to provide size, I mean the height and the width as 0, 0. Then what we can do, this is the destination size as a percentage. Now this is 30, right? So we are asking to reduce the size to 30% from height and from width 30%, right? So now this is like 30% from the original size, right? So if you put like 80% this side and 0.8 this side, so this says 80% as the original size, right? And if you put 5, this is 50% as the original size, 50% from the original size, right? So I think we'll go through size 3, right? So this is like 2 methods that you can use the resize function. So the advantage of using this will keep the aspect ratio in the sense like the ratio between the height and the width. So it will keep it, will protect it and do the resize, right? Got it? So then the task here is, you can see, if you see this image, you can clearly see that there are some kind of connections, right? Overlappings, right? So due to this overlapping, you will see that when we apply contour operations, right? When we apply contour operations, this is not going to work, right? For example, I'm going to convert it to gray, and let's say we are going to apply thresholding, right? So let me show you the image after applying thresholding, right? Let's see. Okay, this is what you have. Now you can see clearly that there are some kind of right, overlappings and connections between the coins, right? So now what will happen if we apply contours, right? So if we apply contours, what will happen? Simply, like if you do contour operations, and now let's say we want to detect the coins, and let's say we want to detect the coins separately. So what we are going to do? Okay, we are going to apply contour operations, right, and detect it. So this is what we are going to get, the final output. Yeah. Yeah, so let me apply the thresholded image here. So this is what you are going to get, right? So you can clearly see that the contours, I mean, the separately, the coins are not detected, right? The coins are not detected separately. Why? Like this is considered as a single contour. Why? Why this is considered as a single contour? Due to the, right, due to like the fact that these coins are connected through this overlapping points, right? Got it? So in order to get rid of these overlapping points, what we can do is we can apply erosion, right? We can apply erosion. So what we are going to do, without doing directly, without directly detecting contours from the threshold image, we are going to apply like erosion, and we are going to like, let's see. So we are going to apply erosion, and then we are going to find the contours in the eroded image. So let me show you the eroded image, so then you will understand. After applying erosion, this is what you are going to see. Let's see. So now when you apply erosion, right, so you can see that right, these connections are removed, right? So this is not done perfectly, but you can see somewhat it's, you can fine tune these values and get a better results, right? So you can fine tune these values and you can get better results. I'm just explaining you how we can do that. So then you can see that they are removed, the connections are removed. So then you can somewhat detect it separate, right? I mean, this is not a perfect result, but you can adjust these values and come up with the good one, right? Come up with a good one. See, right? Okay, so that's the application of the dilation and I mean the morphological operations. Hope you got the idea, right? So now we have another feature, I mean feature extraction method, the edge detection. So we have already discussed about edge detection using the Sobel kernels, right? So you know how to detect edges, horizontal and vertical edges using Sobel kernels, right? So this canny edge detection is another edge detection method, right? So I will keep this to you as a homework, right? So you can read it, and the same example that I did on last day, the lane detection. Now I'm trying to do it using this edge detection, I mean the canny edge detection, right? So I will leave that example to you. All the code and everything are given, so you can go through the canny edge detection. All the things are given. So same example, this is not a new thing, but the early example we did it with the Sobel kernels, Sobel edge detection, but this one we are doing it from separate, I mean different method called the canny edge detection. So you can have a look. So I will keep it to you, right? Okay, so then we are going to move on to the next topic. Our next topic, video processing and object tracking, right? The video processing and object tracking. So this is not a big topic, so we are going to finish it soon, right? So we have only 2 examples or 2 methods that we are going to discuss under video processing and object tracking. So they are background subtraction methods and then the mean shift algorithm, right? So let's quickly go through these 2, and then we are good to move to the day 4, and here we are going to discuss about cascade classifiers, right? Okay, so the first one simply now this topic of video processing and object tracking simply discuss about how we can discusses about how we can track objects, not detect but track, right? How we can track objects in a, I mean in a video basically. right? So that's what we are going to discuss on this example, right? Okay, so in order to do that, right? So in order to do that, we have all right. So we have let me get ready my camera. Okay, so object tracking, right? How we can track an object in a video, right? So the first method is background subtraction method. So this is a quite straightforward method that we can follow, right? So this method assumes that there is a moving, right? There's a moving object in the video, right? And it's going to take two consecutive frames, right? So it's going to take two consecutive frames in the sense, right? So it's going to get the frame at t equals t, right? And it's going to take the frame at t equals t plus 1, right? Two consecutive frames, right? Then directly it's going to perform subtraction, right? It's going to perform subtraction, right? So let's say that, okay, so this is the frame at t plus 1, right? And this is the frame at t, right? So what it's going to do, it's going to directly subtract ft plus 1, frame at t plus 1 from frame at t, right? It's going to directly subtract it, right? Directly subtract it. So this is what we are going to do, right? So now if you are wondering, okay, how this subtraction is done, these are two images, right? How we can perform subtraction between two images, it's nothing but pixel wise subtraction would be performed, right? Pixel wise subtraction. So from each and every pixel, like each and every pixel will be subtracted corresponding pixels. That means, okay, so let's say that you have an image like this, and the second image is this, let's say, right? So this pixel will be subtracted from this pixel, right? Subtracted by this. So subtracted by this pixel, subtracted by this, likewise, right? Then the resultant, I mean, there will be a resultant image. So the resultant image, this is what happens, right? So this value, this pixel value gets subtracted from this pixel's value, this is pixel value, and the resultant value will be assigned here, right? Then this pixel value will be get subtracted from this one, and the resultant will be assigned to this, right? So that's simply what happens in this one, right? So then there will be there will be many values, right? So there will be values in like 0 to 5 range. So then you are going to apply a thresholding, right? A thresholding, and then you are going to get a black and white image, right? So thresholding will be done after subtraction. Then thresholding will be done. Then you are going to get a black and white image. So the assumption here is, so there is a moving object and the background remains constant, right? So that's the assumption here that we are going to make, right? Otherwise, the background also changes, right? So if the background is also changes, let's say, okay, moving camera, right? So this couldn't be done this couldn't be done when the camera is moving, right? So we can't do this for example, camera attached in a vehicle, right? Correct? Since the camera is moving, here we are going to assume, okay, the background is fixed. In order to get background fixed, we have to make our we have to place our camera stationary, right? So that assumption is there, otherwise we can't do that, right? So we assume the background is constant and the camera is fixed. So if there's a moving object, the moving object becomes black. The moving object becomes white and other become black. Why? Right? Why black now? If the background is constant, then let's say this is a pixel value. This value will be equal to this value. So when you subtract it, it becomes white, right? It becomes white, right? Sorry. So if the background is constant, if you consider these two pixels, right? So what will happen here, right? What will happen here simply, Yes, any idea? Yes, then those two are equal. What will happen? Simply this becomes black. Why? The values are equal. So this object was not there. So when you deduct it from here, it will become there will be a value, right? There will be a value, right? Then we apply thresholding and this becomes white. That's how it simply works, right? So here I have, this is how we are going to do it, right? So there is a video, I will show that video. And this is the background subtraction object. So you have to initialize it first and you have to read the image and you have to, if you want to, you can resize, and then this is where you are going to apply the background subtraction dot apply image. Then this will give you the black and white image. I mean this one, right? Right. So this command, this function will do this operation, right? So this function simply does this operation. This operation in the sense it's going to subtract the background from the consecutive two images, and this will be assigned here, right? So the FG mask, right? So when you show it, you will see something like this, right? Now here you can see this is the original image and this is the mask that generated. Now object tracking is not a big deal, right? So if you apply contour operations, right? If you apply contour operations, and you can then detect these moving bikes, right? Can't you? Huh? So you can apply contour operations and you can, I mean, I'm not going to do that here, but if you apply contour operations, you will be able to detect these bikes, right? So that's a something that you could do, right? The other thing is, right? The other thing is that when I mean, now you can see the camera is kind of moving here, right? Camera is kind of moving. So therefore also like you can see that becomes white due to now these leaves are right due to the wind, right? These leaves are moving, right? So therefore due to that also this becomes white. Other than that, right, this is fine, right? So if anything moves, that will become white. That's the issue. Right? So now you can apply whatever the contour operations and detect whatever the object you want, right? Okay, now for example, if I apply it to a video, like I'm in camera, right? So let's see what happens. I'll apply it to my camera. So if I'm not moving, you can see it's not, there's nothing, right? But if I move, right, so it will be highlighted, you can see. Now you can see the ball and my hand is moving, right? Got it? Okay, so this is simply background subtraction, right? So that's another method. Now I'm not going to show you how like object detection is done. Since if you have this, then the mask is there, the black and white is there, the moving objects are in white, and the other all the background is in black. So it's, you can apply whatever you operation you want, thresholding, contour operations, or whatever you want, and detect the moving objects, right? Okay, so the next one, the mean shift object tracking using mean shift algorithm, right? I'm not going to go into that much detail about the mean shift method, since mean shift is something that mean shift is an algorithm comes under machine learning. So it comes under unsupervised machine learning, unsupervised learning, right? It comes under unsupervised learning, and so here simply what basically that you have to do, right? So this is an algorithm, as I mentioned, comes under machine learning, right? So this comes under machine learning, and this is simply, right? So this simply can be used for object detection, but there are a few constraints here. I'm not going to go into that much detail about the mean shift algorithm, since we are going to discuss this in detail in our machine learning workshop about the mean shift algorithm. We will discuss about this mean shift algorithm in detail in our machine learning course. So I'm not going to explain that much about mean shift algorithm that much, but I will show you how we can do object detection here, right? So in order to do this object detection using this mean shift, we need two things, right? Two things. First, we need to have a window, a tracking window, right? First, we have to have a tracking window, and this is nothing but like some XYWH parameters, XYWH parameters, right? So these are nothing but some XYWH parameters. Some XYWH parameters. So what is this about? XYWH. Here, so we have to define a starting window, right? We have now, this is one thing that we want to do first, right? A starting window. Then we have to provide a color, right? Then we have to provide a color like this, right? A color, right? So let me explain you how this works, right? Let me explain you how this works, and let me show you how this works, right? Okay, so let me run this and show you where the, okay. I think, yeah, 0. Okay, right? So I think it's better if I can get the other camera. Let me get the other camera, right? Not this one, probably number 1 camera. Okay, okay, I think the other camera, 0. Okay, right? So yeah. Okay, right. Okay, now I will again run this thing. Right. So now you can see the ball is it tracks the ball, right? See, it tracks the ball, right? Sorry. So not this chain, but it will track any red color thing. So let me show this. I'm not sure whether it's going to track it. Yeah. Yeah, I think that would be better, right? So this one, again a red one. No, you can see. So it's tracked, right? Right. Okay, now how this happens, right? So here we have two constraints. What? We have to provide the initial window. This is called the track window, right? And then we have to have a color, right? So there are two constraints that in order to use this is a good method, you can see, right? So you can see that clearly it can detect, right? So it can, right? So it can detect this object, you can see clearly, right? So in order this to work, right? In order this to work, you have to have like the first, the initial window should be defined, right? Now you can see no, right? So it's not detecting, right? So you have to keep the object that you are interested on detecting, right? So you have to keep the object that you are interested on detecting at the initial window, right? So here I will keep it here. Now let me run it. Now you can track it to anywhere. See? Right? Got it? So what's the trick here? First, the object, that means if you are detecting an object, you have to provide the initial window, like initial window that the object might present in, right? The object might be, right? Got it? So you have to get the window where, I mean, the window of the initial position of the object that you are interested on tracking, right? Then you have to provide the color of the object that you want to track, right? So there are two things that you need to provide here. Other than that, this won't work, right? Now, as I mentioned, if I keep it here, right? If I keep it here and run it, see, this is not tracked, right? So you have to keep it here in the initial window, right? So let me run it again. You can track it now, right? So got it. So you have to keep it at the initial window, right? Otherwise, it could be tracked. Then you have to provide the color, right? The color that you want to track, the color of the object that you want to track, right? So with that, you can use this method, right? Got it? So I'll explain about this mean shift method in our the machine learning course. But for now, I will explain what happens simply. But the theory and all in detail explanation will be given on our machine learning course, right? So here we provide our initial window, the initial window of our object that we want to detect, right? And then we are going to take that image, that part, that XYWH, we are going to take it to a object called ROI. Then we are going to use color conversion. We are going to perform color conversion, and we are going to convert it to HSV, right? HSV. Then we are going to create the mask, right? So we are going to perform color segmentation and get the mask, right? Then we are going to calculate a histogram and normalization, right? So then later, this is how the mean shift is done, right? So after applying the mean shift, this gives you the next window, right? The next window in the sense, the new window that the object is currently in, right? So this is how the mean shift algorithm is applied. So this track window gives you XYWH of the new position of the object that you are tracking, right? Got it? So this mean shift is like, actually, if I explain you it simply, this mean shift is about like, it is like tracking through the shift, right? It's going to track the shift of the density of the pixels, right? Now you can see, if I do it again, I will go to the initial point. Okay, here. So you can see the white density is large here, right? So what I'm talking about here. So okay, this is the initial point. So the white pixel, so it's going to track the density. The shifting of this white pixel. So that's how it's done. So this is what actually done in the mean shift algorithm, and I will give you a in detail explanation in our machine learning course. But anyway, you know how to use this method. Here, the initial window of your object should be given, and the color of your object should be given, and you know how to select the color. We discussed about the color segment topic earlier, right? Got it? So using that method, you can detect this color, right? And color of the object. You can define the color of the object, right? Okay, so that's it. Then what we are going to do, right? Hope you are okay with that. If you have any questions, you can always ask, right? Now I'm going to move on to the day 4 materials, right? I'm going to quickly move on to the day 4 materials. And in the day 4, the main topic that we are going to discuss today is object detection using haarcascade classifiers, right? Object detection using haarcascade classifiers. So today, actually, we are going to discuss only about the application, right? So we are going to discuss only about the application of haarcascade classifiers, right? So we are not going to discuss about in detail how the haarcascade classifiers work, right? And the theory behind the haarcascade classifiers, we don't discuss it today. But what we are going to do is we will discuss it, right? So we are going to discuss it on the next day, right? So we are going to discuss it on the next day. And the thing is, we are going to build up our own classifier, right? So then you will get to know how this classification is done. So today we are not going to worry about how this works, but today we are going to do the application. Today is about the application and how it works and how we can create our own haarcascade classifier will be discussed on the next day, the last day, right? So anyway, the final project today that we are going to implement is this, right? So we are going to develop this kind of a bike count, right? So you can see the bikes are detected, right? And you can see it's counting. So this will be our final goal today, right? But the thing is now here we will discuss about only the application, how we can use haarcascade classifier and do these things, but not about how the haarcascade classifiers are working and the theory behind. We will discuss about that in detail on the next day, right? So let me explain what is a haarcascade classifier, right? So haarcascade classifier is a classifier, right? Object detection. Haarcascade classifiers can detect objects, right? Haarcascade classifiers can detect objects, and when you use haarcascade classifiers, they provide us, right? So there are many haarcascade classifiers. Now I have given you some example haarcascade classifiers with your files, right? So if you go to your materials that I have provided you, so if you go to day 4, you have a set of cascades, right? There's a folder called cascades. So in that cascades folder, you have several type of classifiers. These are called cascade classifiers, and they are XML files, right? XML files in the sense, now don't worry about what the content, the content in the sense, don't worry about like what is there inside of this haarcascade classifier. Probably you won't be able to understand it, right? So you can't understand what this file contains, right? So don't worry about that. But anyway, this is a file, and this is what you call a haarcascade classifier, right? And what this file, we will discuss about how we can basically how we can create or develop this kind of a file on next day, right? Today we are going to only use it, right? So if I explain it simply, this file, right, each of these file is a haarcascade classifier, right? And they can detect a single object, right? So this classifier can detect type, this classifier can detect face, this classifier can detect lower body, this classifier can detect left eye, this classifier can detect license plate, this classifier can detect upper body, and inside this classifier can detect bus, this classifier can detect car, this classifier can detect pedestrian, two-wheeler. Likewise, there are many cascade classifiers. So this single file is a single cascade classifier, and each of them, right, each of them can detect a single object, right? If you want to detect faces, there are face classifiers, right? If you want to detect bikes, there are bike classifiers. But using the same classifier, you can't detect bikes and faces together, right? A single classifier is there for a single object, right? Now you may be wondering, okay, how you are going to get these files? Are they available freely? Yes, they are in the internet. You can search of them. You can search them. So even this link also redirect you to no, not this, but at the end I probably have given you some right here, so some external links and credits, so you can find these cascade classifiers from here, right? So there are many cascade classifiers in I think modules, not modules but data, I hope. Data, yeah, haarcascades. Here you can see some cascade classifiers. Now what this classifier can do, it can detect objects and they are pre-trained, right? They are pre-trained. That means, like, I have given, now you can download it from the internet where I showed you. Now you can go here and there are many classifiers available here in the data folder, right? The haarcascade classifiers are available, right? So you can use them, download them and use them, right? And the other thing is that when you like, I mean, the classifiers that I have given you here, right? So they are simply downloaded from here, right? So that's it. And these are already trained. That means we are not going to train them. Now here, this is something related to machine learning, right? Or AI. The thing is that we have already trained them. Like, for example, this classifier can detect faces. That is a pre-trained one. Using some right. So using some using some data sets, right? So this is already trained. This classifier is already trained in order to detect faces. This is already trained in order to detect eyes, right? This is already trained in order to detect bikes, right? Cars, right? So they are trained already. Now, next day, what we are going to do is we will see how we can train this kind of a classifier, right? Now, don't worry today. Today we are using some pre-trained, trained by others. We are going to use some pre-trained classifiers and do some kind of applications. But actually, in next week we will see, next day we will see how we are going to train this kind of a classifier ourselves, right? Okay. So now, as you are already aware, using a single classifier, we can detect a single object. But nowadays, there are neural networks. They can detect multiple objects from the same neural network. So neural networks are advanced, right? Now, I'm not saying this haarcascade classifier, I mean, haarcascade classifier is a single method, only one method that we can use for object detection. But there are many methods that we can use for object detection, right? There are many methods that we can use for object detection, but this is simply one of them, right? This is simply one of them. One of them. And the other thing is, this is an old method. Like, this haarcascade classifiers came into play in somewhere around like 2000, right? Here you can see this is an old method, but still we can use it. Still, this is useful, but please be aware, this is not the latest method. This is not the state of art method. This is not the most advanced method, not the latest one. The latest one is of neural network, right? Neural networks, right? Right? So neural networks are pretty much advanced than the haarcascade classifier. So they can even detect multiple objects in the same image using the same neural network. But if you use cascade classifiers, using a single cascade classifier, you can detect only a single object, right? You can detect only single object using a cascade classifier, right? But nowadays there are neural networks which can even detect 100 kinds of objects using a single neural network, right? So this is bit old method, but still we can use it for many applications. But keep that thing in mind, there are many advanced methods than haarcascade classifiers, right? But we can still use it. Okay, good, right? Now what we are going to do, right? Now what we are going to simply do, we are going to quickly go through the haarcascade classifiers. Don't worry, we are not going to discuss how it is, I mean, how it is, I mean, how it works, right? So we are not going to discuss about how it works, but the thing here is we will see how we can use it for our applications. And next day, as I mentioned, we are going to in detail develop our own object detection algorithm on next day, right? So haarcascade classifiers, simply they can detect objects, right? As I mentioned, they can detect objects. For example, a single cascade classifier can detect only a single object in the sense like it can detect multiple objects in the same image, but a single type of object. That means, if there are, let's say if there are face detection cascade classifier, right? It can detect only faces, but it can detect multiple faces. It can detect many faces in the same image. It is possible. But thing is, it can detect only a single type of object. That means if it is a face classifier, it can detect only faces. So what it does simply, it get a face. Right? So if, like, let's say, okay, we have a face detection cascade classifier. If we provide the image with the face, what it's going to do is it's going to return us x, y, w, h. That means it's going to return us the x, y of the bounding x, y, w, h of the bounding rectangle of the face detected, right? So that's what it's going to return, right? So if you provide the image with the face, if you have a face detection cascade classifier, what it's going to give us? It's going to give us x, y, w, h of that, the bounding rectangle of that face, right? So how it's done? It's quite simple. We will discuss about this thing in detail on the next day, but for today, I will explain now. We are going to train these things. We have to train them now. The training process and everything I'm going to discuss on next week, next day, but I will explain it briefly today. So how this training is done, these cascade classifiers are pre-trained. So that means they are already trained using large amount of data, like 50,000 images, 100,000 images. So very large amount of data is used. Images are used to train the cascade classifier, particular cascade classifier, right? So what happens simply, right? So these classifiers are trained with this kind of features, right? Now if you carefully see, you can see that the eyes, there are this kind of a black and white edge, right? So it's changing now here from black to white, right? And here if you say, right, so it's black here and black here, and here it's white, right? So there is edge like this, right? So there are many features, lines, edges, there are many features in our faces, right? So they can be converted, or they can be interpreted, or they can be represented using this kind of what you call features, right? So what we are going to do, we are going to show these features to this algorithm, the cascade classifiers algorithm, right? And we are going to say, okay, these are the features of the face, right? These are the features. Now this kind of feature is there, right? This kind of a feature is there in the face, right? So likewise, there are many types of right? There are many types of features. Now if you want more information, you can see them here, right? Read more at the OpenCV official. If you go there, you will see more details, right? So there are many features like edge features, right? So they are in the faces now. We can't exactly see, but if you carefully see, you will, right? So you will see features like this now. There's a black line and then white line, right? So there is two black lines, right? And the white in the middle, right? So it's simply like edge features, line features, right? So in a face, right? In a face, like there are many features, right? So there are many features. So example, now if you, right? So right, yeah, around 60,000 features, 6,000 features in a face, right? So what we are going to do, we are going to train these cascade classifiers with negative and positive images, right? Negative and positive images are basically like positive images are the object that we want to detect, right? If we are developing a phase detection cascade classifier, the positive images are the images of the phases, right? And the negative images, simply negative images are the phases, I mean the images without phases, right? So positive images are the phases phases with I mean images with phases, and negative images are any image without phases, right? So what we are going to do, we are going to get large amount of positive and negative images, and we are going to train it, right? So that process we will explain on next day, right? So anyway, I will show you the application today, right? As I'm repeating, so today we are only going to discuss about the application, and the theory, how this works will be discussed, and we will train our own haarcascade classifier, right? So we will build our own haarcascade classifier on the next day. Today only the application, right? So let us detect phases using haarcascade classifier. In order to do that, what I'm going to use is I'm going to like many cascade classifiers are there, right? So here phases and eyes, we have a classifier to detect phases, and we have a classifier to detect eyes. So two different classifiers. As I mentioned, for a single object, there is a separate classifier that we want to use, right? So vehicle, we have bus, car, pedestrian, two-wheeler, right? So what we are going to do, we are going to do it for a simple example. We are going to get sample images from our samples folder, right? And let me show the image first, then you will see what that image is about. Right. So this is the image, and this is a bit large. So let me resize it. I just explained you how we can resize using the resize command. I explained you how we can resize using the resize command. So I'm going to reduce it to 50%. 50% from the width, x side, and the y side, I mean the height. So we are going to reduce it to 50%. Then this is what we are going to see, right? Now we are going to load our haarcascade classifier. How we are going to do that? Before doing that, we want to convert it to gray, since majority, like 95% of the haarcascade classifiers, they are working with gray images, right? That means haarcascade classifiers, almost all of them are trained with gray images. So they are only working with gray images. So we have to convert it to gray images. They are not working with color images, right? So what we are going to do is we are going to load the cascade classifier. In order to do that, we have a function called cv.cascade classifier. Then you have to provide the path of the classifier, right? So this is the path of my haarcascade classifier, or simply I can get the path here. Right. This path. This is the path that I'm giving here. I mean here. Right. Then you have to provide the name of the cascade classifier, right? The name of the cascade classifier. So the front page default, right? So you are going to get it, and simply what you are going to do here, you are going to provide the name of the cascade classifier, right? Okay. So then we can load it to a right. We can give a custom name for this. Okay, phase classifier, let's say phase classifier, right? Okay, now we have the image that we are going to use, and then we have the phase classifier, right? Then how we can detect the phases? Simple. The function, from this phase classifier, we have a function called the method, simply a method detect multiscale. So this function could be used in order to detect the phases, right? So we can apply the gray image, make sure that you are going to convert it to gray and apply. Then this returns something. So let me refer it as phases, and I will print the output, right? So here just nothing. What we did was we converted our image into gray, then we loaded our cascade classifier from the file in our computer. Then we apply for that phase classifier, we use the detect multiscale function, and we apply this gray image, and it returns us something. So let us print it and see what it returns, right? Okay, so this is the output, right? So this is what phases is about. Now this phases is a just a given name by name given by me, right? So it's not, it makes no sense. Like you can use XY even, right? It doesn't matter. But when you print it, this is what you are going to see. Can you interpret what this is? Or can you understand? Or can you guess what this is? So there is a kind of six rows and 4 columns. So can you understand what this is? So why there are 6 columns? Why there are 6 columns? I mean 6 rows. 6 rows. Why there are 6 rows? Why there are 6 rows? Any idea? So can you remember what I told? Yes, we have an answer. Let's see. Maybe 6 faces. Yes, exactly. 6 faces. That's why. That's why. Now the thing is here, right? The thing here, simply, right? Now I told you when a cascade classifier is there, it detects the object and it gives us XYWH, right? So it gives us XYWH, right? But here there are 6 faces, as you can see, right? So, right, so this is the, right? So this is the, the XYWH, right? And this is the XYW of phase 1. This is phase 2, and this is finally the phase 6, right? That's what this simply says, right? That's what this simply says. Got it? Understood, right? Okay. All right, so that's what it simply says. Now the other thing, right? The other thing is now it doesn't draw it, right? I mean the detection, it gives us XYWH. Yes, it gives us XYWH of 6 faces, but it's not going to draw them, right? Not going to draw them. So we have to manually draw them. So what I'm going to do, I'm going to go through each and every face, right? That means simply face in the sense like I'm going to go through each and every XYWH, right? So even you can do it like this as well, right? So I'm going to go through each X and XYWH. Then I'm going to draw, right? So this, you know that this will run 4 times, 6 times, right? Why? There are 6 rows, right? So there are 6 rows. So what will happen? Simply this will run 6 times, right? And each time I'm going to get XYWH, that means X, Y, W, and H. Then I'm going to draw a rectangle in green color with 2 pixel thickness, and I'm doing XYWH, right? So this is what you are going to see. Now now the faces are detected. You can see now they are detected, right? Now they are detected. Got it? So this is how simply you can detect faces, right? Got it? So now then what you can do is simply you can I will discuss about this later, later, right? Now you can apply the same thing to a video, you know, right? So this is how we are going to do it for an image, right? This is how we are going to do it for an image. You can see, right? This is how we are going to do it using for an image, right? And the same thing you can do, like whatever the thing that we do, we are going to put it inside a loop, right? The same thing that we did, we can put it inside the loop, and we can do it for a video as well. Only this line changes. So we are not going to read the physical image. Instead of that, we are going to get a frame from the video, right? So then the other lines of the code are the same, right? So then this is how we are going to apply it to a video, right? So you know these things, right? So if you do it for an image, it's nothing. You can do the same thing for a video as well, right? So this is how we are going to do the video, right? Okay, so then how we can detect faces and eyes? Like, okay, now let's say how we can detect two things in the same image, right? So like two objects in the same image, how we are going to do that? Two objects in the same image, right? Now we know how to do it for a single object, right? Single object in the sense, here we know how we can do it for a face, right? So we know how we can detect faces. So this is how we can detect faces, right? Now I'm going to explain you how we can detect like two objects. For that, I'm going to take the example detecting faces and eyes together in the same image, right? So it's quite simple, nothing but simple, right? So now this is how we are going to do it for the face. So you know that this is something that we did earlier, right? So this is something that we did earlier. This is something that we did earlier, right? So same thing I'm going to do for, right, eyes. So it's nothing but, see, I'm going to get another, right? I'm going to get another classifier, right? So I'm going to refer this as eye classifier, right? I'm going to refer this as eye classifier, and I probably have to change the name. Now this is the eye classifier, right? I'm going to give the name here, right? So then, okay, the next classifier is already taken here. Then you know, like this is how you can detect. I mean, these three lines, I mean, these set of lines, you can use it for detection. Now this is how the faces are detected, and this is how they are drawn, right? The same thing we are going to do for the eyes as well. I mean, these are not like face. I mean, you can put any name here, right? So they are not need to be faces or eyes, right? Right? Got it? So I just put faces and eyes in order to make a sense, right? So otherwise, no. Right? Then I'm going to use like yellow color to draw eyes, and you can change these values if you want. Since we have used XYWH earlier, we can use EX, EY, eyes X, eyes Y likewise. Not necessary, but right. So let's see now. See now, right? Eyes are detected. Uh, why these two colors are changed? I can't. I mean, I put yellow for eyes. Why? Here I have I have changed the names, right? So that's why. So this should be face classifier and this should be eye classifier, right? Got it. So anyway, it's nothing, right? So you can see it's nothing. What? So this is how we are going to draw the eyes, and this is how faces, and this is how we are going to detect eyes. Right? Um, till when the lecture will be? I'm taking around like half an hour, 20 minutes more, right? Maximum half an hour, right? Maximum half an hour. Okay, so that's how we are going to detect two objects, right? But there's a small issue here, right? What's the issue? You know that the faces gives us like, when you detect a face, you are going to get XYWH, right? Right. So you know that now this is not applicable for all the all the scenarios, but for this case, it's a special thing that I'm explaining, right? Right. What's the special thing? That we know that, I mean, how this detection is done. I want to explain that also. Right? How this detection is done. There will be a window, right? So there will be a window going through the whole image like this, the sliding window, right? So there is a sliding window, 1, 2, 3, likewise, it's going to go through the whole image, right? So when there is an object detected, right, that XYWH is given, right? So that's how it's done. Understood? So there is a classifier going through the whole image like this, right? So there is a classifier sliding through the whole image like this, and when there is a face detected, it's going to get this XYWH and give us, right? So it's going to give us XYWH, right? Now, you know something, what, right? So you know that if you want to detect eyes, right? Then again, if you want to detect eyes, again, there will be a window goes through the image, right? When you want to detect eye. But we know that there will be eyes inside faces, right? Definitely there should be a face to, I mean, eyes to be there, right? Therefore, what we can do is we can go not, we can save time. So when it trying to detect eyes, it's going through the whole image, but instead of going through the whole image, what we can do, we can make the algorithm only go through this face, right? So then the time will be saved, since we know that eye should be there definitely inside the face, right? So see, let me apply the first method that I explained, right? So this method. So this is simply nothing but we detect faces and eyes later. So if you run this one, you will see the video get, right, so it's quite slow, right? So you can see it's quite slow, right? It's quite slow. Now what I'm going to do, instead of doing that, right? Instead of doing that, detecting faces and eyes separately, what I'm going to do, inside, now this is face detection. Inside that face, right? What I'm going to do, I'm going to get y to y plus h, x to x plus h, y to y plus h and x to x plus w. And I'm going to take that cropped into a image called faced image, right? So this is nothing but I'm going to get y to y plus h and x to x plus w. That means I'm going to get, okay, what? To this point, right? Right? X to x plus w and y to y plus h, right? So I'm going to get this crop. That means the face cropped. I'm going to get the face cropped here, right? And in that image, I'm going to detect ices. So instead of searching for ices inside the whole image, now it only search for ices inside the face, only the face, right? So then the others are the same. So then this will make the process bit fast, right? I think, yeah, the path should be yeah, the correct path is not given. That's why. Anyway, right? Okay, right. So so when you do that, you can see now it's a bit faster, right? It's fast. Why? It's fast since, like, instead of going through the whole image and searching inside, instead of going through the whole image and searching for the eyes, now we are only detecting eyes. We are going to go through only the inside the face and search for eyes, right? So this is not applicable for all the things. I mean, if you want to detect if you want to detect bikes and cars, right, this method won't be applicable. Why? Right? Why this won't be applicable? since this won't be applicable in since like there won't be a bike inside the car, right? So that thing you have to do separately, but faces and heights, since eyes are inside the face, you can, right? For each and every face, you can detect eyes now, right? So you can see this is inside the for loop. Otherwise, you are going to do it separately, right? So here, for eyes separately and for face separately and for eyes separately. Now here, we are going to get this inside the for loop of the face, right? So then inside the single face, we are going to search for eyes, right? So we are going to crop the face and eyes will be searched inside the face image, the cropped face, right? Got it? So that's how we are going to do it, right? And there are some other parameters that we can use and adjust this, right? So there are some parameters that we can use and adjust our what you call this, right? So in the detect multi-scale, we can provide, this is the min neighbors, right? And the scaling factor, min window size, max window size. So there are some parameters that we can use in this detect multi-scale and adjust our what you call the accuracy or the quality of the object detection, right? Got it? So we can change these parameters and adjust we can tune the object detection, right? So more details about these parameters are given in this link, right? Read more about detect multi-scale function, right? So if you go there, you can see that the values that we can pass, scale factor, min neighbors, max size, min size, right? So they are explained in detail here, right? So you can change them and see how they are going to affect to your detection, right? Got it? So I will see where are those values, yeah, right? So these values, you can go to that link and see how these values affect your detection, and you can tune them and create a tuned algorithm for your detection, right? Okay, then what you are going to do, right? So I will keep that for your reading, right? So go here and read it, right? Now, then what you are going to do, we are going to move on to our application today, right? So very interesting application. So this is what we are going to do today, right? We are going to implement a bike detector like this. I'm not saying that this is perfect, right? I'm not saying that this is perfect, but we will go through this and see how we can implement this kind of a thing. Now, this is what you should do, right? I mean, this thing anyone can do. This thing in the sense, detecting something and drawing rectangles. Okay, this is the face, these are the eyes, right? This is the face, these are eyes. Likewise, detecting and drawing rectangles around the detected object is nothing. It's something that everyone can do. But this is something interesting. Why? This is the application of it, right? So we can detect it and we can use it for further application. We can improve it and use it for this kind of meaningful and a useful application. So that's what you should be focusing on, right? So let us go through this and try to implement this, right? So in order to do that, we have a cascade classifier, that already trained cascade classifier in the vehicles, and now they are in your materials, right? I mean, in your day 4, you have something called cascades inside that, vehicle and pedestrian, so two-wheeler. So this is the cascade classifier that we are using. Now you have many cascade classifiers that you can use, right? Now the thing here, the code remains the same, right? Now this code that I written this for detecting faces, right? I wrote this code to detect faces, right? But the same code, you can just change the cascade classifier here, and you can use the same code for detecting cars, right? And you can change the video here, and you can use the same code and change the cascade classifier and you can detect cars. So the code remains same, right? You can change the cascade classifier and you can detect any other object, right? So we will be using the same code, right? The only thing that we are going to change here is the cascade classifier that we are going to right use. So let me take this path, right? And I'm going to I'm going to take that path, right? So let us first see the sample video that we have. So I'm going to get the CV2 library and I'm going to get the image, the video file, and then I'm going to, yeah, that video file would be enough. Then I'm going to have infinite loop here, read one frame from the video source, right? One frame from the video source, and just I'm going to show it and right, do this stuff. That's it, right? So I'm just trying to show you the video, that's all. Right? This is something that you know, right? So we have a video like this. Okay, so this is the original video, and probably we have to resize it, otherwise we can't see the full video. So I'm going to resize it, so you know how to resize it, right? Okay, so this is the video now. Now what we can do is we can get the cascade classifier here, right? Then what we can do, you know how to do it. You can you have to convert it to gray first. We discussed this, right? You can convert it to gray first. Then you can apply it to the cascade classifier and detect whatever the bikes, right? Then you can go through an image, go through the detected XYWH, right? You can go through the detected XYWH and draw a rectangle, right? So let's see. Nothing is the thing is here we haven't applied yet. I want to apply image here, right? Okay. Then you can see, okay, bikes are detected. So this code is nothing, right? This code is nothing, but I explained this code, right? I only change the video and I change the cascade classifier. So this is the same code that we written for the faces, right? Now this code, the same code is detecting bikes, since we changed the cascade classifier and we change the video, so it's detecting bikes, right? Now what we need to do, the rest. So that's something. Now this is something that everyone can do, right? So like it's 10 lines of a code, right? It's a code of 10 lines, nothing, but this is something that anyone can do. But we need to move further, and we need to detect the bikes and count them then, right? And we have to count them and show them, right? Got it? So that's what we are going to do, right? So what if I show you the final output here? So this is something that we are looking forward to, right? So we need to have a line. Here you can see we need to have a line, right? So first let us draw that line, right? So what you can do, I'm going like, I have already done this. So these values you can't get directly, right? You can't get these values directly, but I have done it. So I know the values, right? So the line that I used to, like, these are like trial and error. I check these values. So I got the appropriate value, right? So from the height, what I'm going to do, I'm going to deduct 200, and that's where I'm going to draw the line, right? So you know, in order to draw a line in OpenCV, you need to have this 0.1 and 0.2, right? 0.1 is nothing but x coordinate is 0 and y coordinate is height minus 200, and this point simply width, height minus 200. So those are the 2 points, right? So what I'm going to do, I'm going to get the height and the width of the image, right? So I'm going to get the height and the width of the image, right? Height and the width of the image, shape 0 and shape 1 will give you the height and the width, right? So then I'm going to get the line y, right? So the line y, what line y in the sense, line y is like the y coordinate of this line, the y coordinate of this line. So it's nothing but the height minus 200. Why you are putting height minus 200? Why you are getting height minus 200? That's a appropriate value I got from trial and error, but you can come up with your own, right? So this is not fixed values. I just got the appropriate value from trial and error, right? So then what you can do is you can draw a line, right? Simply you can draw a line, right? How we are going to do it? Nothing but simply but 0 line y, right? 0 line y and width line y. That means nothing. This is the point 1, 0 line y, width line y, right? So that's the point. I mean, point 1 and point 2. See, right? So the x coordinate is 0 and y coordinates height minus 200. So 0 height minus 200, and here it's the width, and y is height minus 200. So width into height minus 200, right? Got it? So what I'm going to do here, I draw a line, right? From yellow color, thickness of 2, right? So that's what happens. So when I draw the line, right? Now there's a line, right? But line, there's a line, that's all, right? It's not going to detect anything, right? It's not going to detect anything, right? Got it? So what we can do now, we can initialize a variable called count, right? We can initialize a variable called count, right? Now you can see that, right? So we want to detect the bike passing the line. So if we want to, like, we have to detect if the line, if this bike passes the line, then we have to increase the count by 1. So that's the bike count simply, right? Right. So this is this coordinate line y. We have initialized a variable called line y. So it's nothing but height minus 200. So this line is passed by this something, right? What happens? We need to detect it. We need to increase the count by 1. Count plus plus, right? Right. So count is initially 0, and if this bike passes this line, we have to increase the count, right? So you can see, I mean, the x coordinate of the bike is not going to be a issue here, right? The x coordinate, it can be anything. X coordinate, it can be anything. Only the y coordinate is a matter here, right? So therefore, I mean, no matter what's the x coordinate of the bike, so we have to worry about this. I mean, when there's a bike, you have x and y both, right? So we have to worry about the, sorry, this is y, this is x. Right? So you have to worry about the y. So if this y coordinate of the bike passes this line, then we can increase the count by 1, right? Got it? Got it? So what we can do, okay, simply, now this is where your bikes are detected, right? So this goes through each and every bike of the detected frame. So what we are going to do, if the if the y, right, if the y coordinate of the bike, right, that's what it is, right? So it's nothing but here, if the y coordinate of the bike, or we can do it like y plus h. Now here y, this is y, but this is y plus h, right? So either y or y plus h passes this line, we can go through y, right? If the y passes this line, we can increase the count, right? So what we can do, okay, if y is greater than line y, that means that it passes the line, then we can increase the count by 1, right? Count equal count plus 1. So let me show the count. So where I'm going to put the count, right? I'm going to put something called something like this, right? So let me remove this and show you what I'm trying to do, right? So I'm going to put something called motor bike count, and I'm going to put the count variable. The count variable is an integer, so I have to convert it to a string, and I'm going to put it in 10, 50. X is 10, y is 50. That means I'm going to put here somewhere here, right? 10, 50 here, right? X coordinate is 10, y coordinate is 50. So that's where I'm going to put motor bike count, right? Then I have a string converted to string. So I mean integer converted to string, right? Not this one, sorry. This, right? So we haven't increased the count yet, right? We haven't increased the count yet. I will put it here, right? So this is something like this. Sorry, this is not this, but this. Right? So you can see it's not clearly seen, right? Here, it's not clearly seen. So we will we will have a red color line, right? Red color line in order to highlight that thing, right? So I'm going to have I'm going to do this. So make sure this is where I'm going to have this red line, right? So the red rectangle from 0 to 17, 0 to width, I'm going to make it red, 0, 0, 2, 5, 5. So that means, so from 0 to 70, right? From 0 to 70 and 0 to width, this part, I'm going to make it red, right? Then I can clearly see the, right? So in order to, this should be done after the detection, right? Why? Otherwise, the image will be that rectangle of the image will be removed from the image, right? That red part, the red color rectangular part will be removed from the image before applying it to the algorithm. So this should be done after detecting. So then no change will be done for the detection. No impact will be done for the detection, right? So the original image will be applied to this. After detecting it, then only we are changing that color, right? So now this is what we are going to see. Now still the count is not increasing. The count is not increasing. So what I told you here, simply we are trying to do something like this. When the bike, now we know that if bikes are detected, this loop will be executed, right? So if the particular byte the y coordinate of the bike, if it is greater than the line y, right? So line y, what we can do is we can increase the count. Right? We can increase the count. So let's see what happens now. Now there's an issue, right? Why? Now the count is increasing, but it's not according to the number of bikes, right? So it's continuously increasing, right? So what happens here? A simple thing happens, right? So you can see, right? So read our condition. Right? So what happens? When the y is greater than line y, the count is increasing continuously. So what happens when it passes the line, right? So if it passes the line, right? So whenever the y is greater than the line y, so when the bike is there, it's increasing here, it's increasing, it's here increasing, right? So until the bike is, until the line y of the bike is greater than the line, the y coordinate of the bike is greater than the line y, it keeps increasing, right? So this is not going to work. See? So then what we can do, okay, we can say, okay, when the y is equals to line y, that means when the exact moment, right? Okay, so now the bike is there, right? And earlier, this moment the count will be increased, here count increase, here count increase, here count increase. Now it keeps increasing. Now what we are going to do, whenever this is equal, that's only where the count is increased. So now here the count won't be increased, right? That will be increased here, right? So let's see now what will happen. Right? Now it's not increasing. Why? You can see it will be increased some, not at all, not all the times, but sometimes it will increase, but it's hardly increased. You can see it's hardly increased. Why? Since you can see this is not a very solid detection, right? It's not a very robust detection, right? It's like Like sometimes it detected, sometimes it's not, right? So it's disappearing sometimes, right? Got it? So when it passes line, that exact moment, what I mean by the exact moment, so it should be on the line in order to detect like this. But this moment won't come, right? Why? So the detection is sometimes detected, sometimes it's not detected, right? So therefore the exact moment won't come, right? See, that's why the count is not increased, right? So in order to get rid of that, what we can do, right? What we can do is we can have a range like this, right? Right. So what I'm going to do is I'm going to get the center of the line, right? So center of the bike, right? So center of the bike, you know what? Center of the bike is this point. So it's y. Now here it's y. This is h. So this point is nothing but y plus h divided by 2. I'm going to see, okay, if the y plus h divided by 2 is in range like greater than 6 or less than 6 compared to the line, then we are going to increase the count, right? So if you do it like that, right? So what I can do is I can include it something like this. I'm not going to exactly check whether the line y equals to the y, but I'm going to give a range. I'm going to calculate the center of the bike, y coordinate plus h divided by 2. Then I'm going to check whether it's like in a range greater than 6, I mean line plus 6 and less than line plus. So I'm going to check whether it's in a range of values. Then the count will be increased, right? So these 6, why you are going to put 6? I checked it and this is the best value, right? So that's why. So then if you run this, you can see not perfect, but good than the earlier cases. It's not detecting perfectly, but detecting somewhat good, right? Detecting is somewhat good than the earlier cases, right? Okay, now here the line is not changing, right? So you can see the line is not interactive, right? So what you can do is when there is a kind of a detection, I'm going to, now this is where we draw the line, right? The white color, I mean the yellow color line. So when a bike is detected, count increases. So here what I'm going to do is I'm going to change the line, the yellow line into red. Then you are going to see like interactive thing when the line bike is detected, the line changes to red, right? So let's see. Right? You can see it, right? So I'm not saying that this is perfect, but it's somewhat okay, right? Okay, so that's the whole project, right? So hope you can go through this yourself and try to figure out, I mean, try to change these things and try to apply it to your own application. Now that's what important, right? So I tested these 4 values and I do trial and error, and this is what I got, right? So when you use it for your application, you may have to change these values and you have to come up with your own values, right? And you have to think and do these applications. The thing is, now as I mentioned, this is something that everyone can do, right? Anyone can do this thing, right? So it's not about that. So this is what you should do. You should use this kind of things for your own application, right? So this is a good example, right? Okay, so that's it for today, right? And on next day, 5th day, what we are going to do is we are going to do our own cascade classifier, and we are going to train our own haarcascade classifier. Not exactly a haarcascade classifier, but we are going to do something similar to that, and we will build up our own object detection using machine learning. So the day number 5 will be an interesting day, since we are going to learn machine learning and build up our own object detection. Now today we use object detector trained by someone else, right? So we just used it, we didn't train it and we didn't build it. But day 5 we are going to build it our own and we are going to use it, right? So we will meet on next Monday at 7. So if you have any questions, you can ask them now. If you don't have any questions, you can leave. The video will be uploaded, and any questions you can ask, otherwise you can leave. We will meet again on next Monday. Monday at 7. Can't we do like whenever it will draw rectangles, will increment count? Yeah, that's also possible, right? You mean, okay, without this line, right? Without this line, you are asking like if we can increment the count. Yeah, I'm not sure about that, but anyway, a good idea. Let's see what will happen. Right? So we can check it, right? So we'll see. So this is what I think this is what you are referring to, right? The thing is, can you see? For each and every rectangle, it increases the count. The thing is now, can you understand what happens here? For each and every frame now, when you have a new frame, right? When you have a new frame, so here it takes a new frame, again a new frame. For each and every frame, it draw different rectangles, right? So each and every frame, it's going to draw different rectangles, right? So each frame, let's say, okay, there are 10 bikes, right? There are 10 bikes in a single frame, right? So 10 rectangles will be drawn. So count will be increased by 10. Count will be set to 10. In the next frame, there are 10 bikes again. The same 10 bikes are there, right? So 10 rectangles will be drawn for the next frame. Again, value becomes 20. For the next frame, let's say the third frame, there are 9 bikes. Then the value will increment by 9, right? But actually there are 10 bikes, right? But value becomes 30, right? Understood what happens here? Got it? That's why it's not going to work. Okay, all right. Okay then. So thank you so much, and we will meet again on Monday, and we will start with machine learning tutorial. You will get videos soon. I have already sent it to the coordinator. I will ask him. I thought that the videos are distributed among yourself, but I will ask him to distribute the videos soon. Right? I have uploaded all the videos, and I have provided him the link as well. I thought I think he forgot to share it with you, but anyway, I will ask him to share the videos. Right? Okay. See you there.